want to go over the answer key to geologic sequences. In order to answer these questions, you will need your geologic time notes with the different rock types and the principles, and even the definitions of conformable and unconformable. So make sure you have that sheet out before you start. The first section's pretty simple, just to get you warmed up. The first section's on what type of rock makes up each of these layers. So for A, the dashes indicate shale, which is a mudstone. The dots in B represent sandstone. Each of those represents a different grade of sand. C is another layer of shale, which is common. And D is limestone. So all of these are sedimentary layers. They're formed underwater. You would find these at different locations as you walk from the beach out towards the middle of the ocean. Because there's no erosion here, because all of these are deposited underwater, the process occurring is deposition. It means you're making layers. Now, if we had said it was erosion, we would be erasing layers, and that's not the case. I don't know why, it seems like my screen froze there for a second. So now all of a sudden you see the making layers for deposition, which is what's happening here. If there was erosion, you'd be erasing layers. We would see a wavy line like we see down here. Erosion happens on land, and deposition happens underwater. That's just kind of a good fact to know moving forward in this unit. And the next question is pretty simple. It says list the 4 layers in sequence from oldest to youngest. The youngest is always going to be up on top. That's the most recently deposited. So we'll start at the bottom. D, C, B, A. And the reason we know this is from the principle of superposition. Superposition simply states that the oldest is on bottom. It formed first. And over time, the layers above it formed. Sequence 2 is very similar. We have the same rock types, just in a different pattern. So we assume this is a different location. A is sandstone. B is limestone. C is shale. And D is sandstone. So again, all formed underwater. Those layers were each deposited as sedimentary rocks. But E represents an unconformity. So this wavy line here is an unconformity. An unconformity is simply either, you could say, erosion, which is erasing the layers away, or if you want to go a little fancier, you could say it's a break in the rock record. That's kind of what you would find if you looked it up on the internet or in your textbook. Basically what we're saying is there used to be more sandstone here. Some of it got eroded away. We don't know how much because it was erased. The history of this area was erased. Maybe there had been seashells. Maybe there had been some campfires. Something on the sand that we no longer see because erosion broke the rock record, so it's not continuous. We don't have a continuous story. And erosion is the action of just wearing it away. Now to list these 4 layers in sequence from oldest to youngest, again, it's going to be D, then C, then B, then A. D is on the bottom, A is on the top, so again, it's superposition. Don't be surprised by that. Superposition is a really common principle. It's very basic. So when in doubt, stick with superposition. Now sequence 3 is a little bit fancier. It's kind of got more happening in the story. We have a new rock type as well. A is sandstone. B is limestone. C is conglomerate, which is the new one, but it's still depositional, it's still sedimentary, and D is our shale. So again, this is a different location. This is a different story. So is this sequence conformable? Yes, it is. There is no erosion here. Everything goes in order, one layer after another. Layer C contains larger sediments. That's these black blobs. These are like gravel compared to the sand in the background. Which one's older? Well, the older one is going to be the larger sediments. They existed before layer C existed. Just like chocolate chips exist before a chocolate chip cookie is made. You add them, you stir all the dough together, you put it in the oven, bake it, now it's one unit. Conglomerate's like a chocolate chip cookie. You add your ingredients together, when it's all done, you call it conglomerate. But the larger sediments existed first. They used to be part of a different layer that was probably lower down or maybe up a hill, had broken off and rolled into the sand before it got locked down as conglomerate. And the principle that we use to explain that is called the principle of inclusions. Because these larger sediments are included in the conglomerate, but they existed before they were included. So I'll stop the video there, and I'll make another video for the back of the page. This front page should have been pretty simple for you. If you have any questions, be sure to ask.